Hello, I am Laura Wickstrom. I'm from KU Microbiology 402 from the fall 2020 semester. I will be using yeast to show fermentation. Fermentation using yeast can be used in a variety of different products, one being bread and then another being wine. So to begin this project or experiment, we are going to get 2 containers, or in this case, 2 empty water bottles that have been cleaned just with soap and water, and then we're going to label them A and B. So now that our bottles are labeled, we are going to put a tablespoon of yeast into bottle A, a tablespoon of white cane sugar into bottle A, and 1 cup of warm water from the range 105 degrees Fahrenheit to 115 degrees Fahrenheit. In bottle B, which is our negative control, meaning that no fermentation will take place, we are going to put a tablespoon of white cane sugar and a cup of water from the same temperature range. Okay, so now that the yeast, water, and sugar are added to their respected bottles, you'll want to gently swirl the bottles before placing the balloons on top, and then just watch for bubbles and observations. I will be using pH, physical observation, and gas production as my my 3 characteristics that I'll be looking for fermentation. Alright, it's now been 3 hours after the initial start of the experiment. Bottle A, you can see that there is carbon dioxide that has filled the balloon. Also, there has been bubbles that have raised from the initial line 1 when we first started, and they've gone down since then. Also, the water in bottle A is cloudy, and there is sediment sitting on the bottom of bottle A. Bottle B, there has been no change besides the dissolving of the sugar. And then also there's been a vacuum created in bottle B due to the temperature change. Alrighty, we are about 7 hours after the initial start of the experiment. As you can see in bottle A, more carbon dioxide has been produced and inflated the balloon more. As the same as last time, all the bubbles have fallen to the bottom or popped, and then there's sediment on the bottom of bottle A. Bottle B is still unchanged, no fermentation has taken place. Alrighty, we are about 24 hours after the initial beginning of the experiment. As you can see in bottle A, most of the liquid has separated into the sediment at the bottom and a lightly cloudy solution above. Also, the balloon has started to deflate, the carbon dioxide has escaped, and then in bottle B, no change. So we can conclude from our results that fermentation did take place. In bottle A, the pH was slightly lower than initially recorded. In bottle B, there was no pH change. Also, when I took the balloons off, there was a lot of gas released. Also, when the balloon was taken off, you could note the smell of it, and it was, in bottle A, kind of an older smell of yeast, and then in bottle B, it didn't smell like anything.